Welcome to our video about functions. Today we're going to talk about what is a function. We're going to look at this through the lens of a soda machine. Hopefully you guys have used a vending machine before. When buying a soda, Miss Whitney, she pushed a button for lemon twisters. And she got a can of lemon twister. Awesome. Later she went back to the same machine and she pushed the lemon twister button. But this time she got a can of Blast. Is the machine functioning consistently? I would say no, because when she pressed lemon twister the first time, she got lemon twister, but when she pressed it again, she got a different result. So she got a different can, even though she pressed the same button both times. All right, let's check out the next example here. We got Brandy, and she pushed the top button for Blast, and she received Blast. Her friend Miguel also decided to go for Blast, and he got Blast. Each of them asked 5 friends to push the 2 Blast buttons. So there's a ton of people pressing the Blast button, and they all got a can of Blast. Would we say this machine is functioning consistently? We'd say yes, because every time they pressed for Blast, they got what they wanted. They got Blast. So that is consistent. All right, let's check out this last example here with Lautfi. She pressed a button for Slurp, and she got a can of lemon twister. Still later, Taisha noticed that everyone who pressed Slurp also got lemon twister. Is the machine functioning consistently? Well, we would say yes, because consistent, it might not be giving you what you want, right? Like I asked for Slurp and I got lemon twister, but it's consistent because everyone who pressed Slurp got lemon twister. So we would say yes, this machine is functioning consistently. This machine is functioning consistently. This machine did not function consistently because when I pressed the same input, I got a different output. So for defining our function, a function is each input has exactly one output. All right, so each input has exactly one output. We can see here that lemon twister is the same input, but I had 2 different outputs, so that's why that didn't function. But these other 2 machines are functions because every time I press the same input, I got the same output. Every time I put the same button here, I got the same thing every time.
All right, guys, we have 3 tables right here, and we are going to go over these 3 tables and see if we can figure out if the function is consistent, and then kind of talk about why. So if we look at this first example right here, this is another vending machine example, but instead with types of candy. So we have button number 1, 2, and 4, and 3. So button number 1, we can see gives us Sticks candy, and then we press button number 1 again, and we get Sticks candy again. And then we press button number 2 and we get M&Ms. That seems good so far. And then we press button number 4 and we get M&Ms as well. So even though we press 2 and 4 and they give us the same output, that still follows this rule so far because each input that we had gave us exactly one output. Okay, and then we come over to this example right here. So if we press 2, it now gives us duds. But when we press 2 over here, it gave us M&Ms. So is this function consistent? No. So we can say that it's not consistent because pressing 2 gives us 2 candies. Now we're going to come to the second example. And this second example, we're just looking at numbers. So if we look at each input, we have 7, -2, 0, 4, 9, -3, 6. So we have all different inputs. So we don't have an input that repeats and gives us a different number. So we can say that this is a function. Okay, and the last one is right here. If we look, is there any inputs that repeat? Yes, we have a 2 right here. Sorry, it's hard to see. And we have a 2 right here. Okay, so if we press 2 the first time, we get 9, and then we press it again, and we get -8. So this one is not functioning correctly. So this one would not be a function.
All right, we're going to translate the idea of functions to now graphing form. So remember with our table, we had our input and we had our output. When this turns into a graphing situation, our input kind of represents our x values and our output represents our y values. Remember with graphing points, that x is our horizontal axis and y is our vertical axis. So in this case, we want to check, is this a function? So remember our definition is that each input has exactly one output. So I'm going to look at each of my x values. So I'm looking here at -3, and I see I only have 1 dot here. So every time I plug in -3, I get out a 1. So that checks out. Okay, what about -2? -2, okay, I only have the 1 dot here. Awesome, that works. -1, gives me -1 every time. There's no other dots here, so that checks out. Same here, 1 gives me 1, 2 gives me 3, and 3 gives me -2. So this is a function because there's only one output for every input. Now, what if the graph looks something like this? What if we added another dot here? Now it's not a function because when I plug in 1, I can get out a 1 or a 2, and so my graph isn't a function because there's not one output for just the one input. There are 2 different outputs. So this is not a function because of this point. So I would have to remove either one of these points in order to get this back to a function. You'll have a question like this on your derivative assignment where it's asking you like the minimum number of points you need to remove in order for it to be a function. So in that case, this would be 1. If I had another one here, I would need to remove 2 points in order to make it a function again.
All right, now we're going to look at a graph that looks something like this. So if we look at, let's say, this input right here, okay? I know that since it crosses this point, definitely that's one of the outputs right there. But also another output is right here. And because this is an arrow, it's going to keep going. So there's an output up here. So already right off the bat, we can tell that this is not a function because this specific input has 3 outputs. And then if we look over here, this input as well is going to have those. And because this is an arrow, it's going to keep going around forever and ever. And so one way that you guys can tell if a graph is a function or not is called the vertical line test. So if you can draw a vertical line down your graph and it hits more than 1 point, you know that it's not a function. All right, we got one more example for you guys. Again, we want to check that each input has exactly 1 output. Just like Emma was showing you guys, we can do the vertical line test to see if this is a function. If I draw a vertical line, I'm going to do mine dashed. Okay, it's totally not straight, but that's all right. Looks like it only hits it at 1 point, and if you imagine this line moving across, we want to make sure it hits only 1 point exactly. So I'll just draw several. Imagine this is like a time lapse. The line is moving along and it only hits the green graph at 1 point every time, right? If we kept going, so again, imagine this is moving along from left to right. It only hits at 1 point. So yes, this is a function.